Good afternoon, everybody. This is student meteorologist Eric Drewitz with Weather International. Currently, we're looking at the 15Z GFS 500 millibar wind analysis, and we have a big ridge here in the western U.S., which is currently helping to fuel the wildfires. It's really causing some hazardous fire weather. There's been very little to no rain in the past couple months, coupled with now with this ridge bringing intense heat to the region. So if there's elevated thunderstorms that affect the higher terrain, that could definitely trigger some wildfires out there. And then moving across the east, we have a little bit of a trough in the east. Looks like around the Great Lakes region, so maybe some cooler temperatures towards the eastern United States. Shout out to my buddy in Marblehead, Massachusetts, Scott Meyerson, for telling me that your house has never felt like summer at all this year so far. So to put it in perspective, this summer is very interesting. Record heat in the west, and then my buddy here in Marblehead, Massachusetts, saying he's never even seen summer at all this year. Now moving around the world to look at the global circulation real quick first. Although I'll get back to this when I talk about Europe later. But currently over the Atlantic, you have a big trough in the eastern Atlantic, which is kind of enhancing this big ridge over Europe that's causing some real intense heat into Western Europe right now. I'll explain about this later, but since the ridge is in Western Europe especially, that's where the Mediterranean Sea gets a bit narrower, so then that'll cause warm air to advect from Africa, and that hot air that advects from Africa won't have as much water to go over to moderate the air as it would if the ridge was a little bit eastward, because the western Mediterranean Sea gets pretty narrow. Now heading a little more east into Eurasia, Eastern Europe, Western Asia. Looks like we have a big trough again, kind of coupled with that ridge. We have a big trough to the east over Eastern Europe, like Greece, Turkey, Western Russia, and then moving eastbound into Asia. We have a bit of a trough in Eastern Asia, going over areas of Eastern China and both North and South Korea and Japan. Now we could bring up sea level pressure quick, and yeah, you have a big area of low pressure over Eastern Asia. South Korea, North Korea, Eastern China, and Japan. You have a big area of high pressure over here in Western Europe, because high pressure is associated with ridges, which is evecting all this hot air from Africa into Europe. Looking a little more south now in the southern hemisphere, I guess. Let's look at South America, since I haven't looked there yet. Yeah, it looks like generally high pressures over most of the region for South America, and then I guess looking at Australia quick, same kind of deal down there. Looks like a strong high pressure system actually is currently dominating southern Australia. 1030 millibar high. But they're in winter right now, so you usually get stronger high pressure systems in the winter, because they usually like to occur where there's a very cold air or where there's cooler air. And in the summertime, a lot of times over the desert Southwest, you get a kind of a low forming there from all the hot air. Anyway, I guess looking into Canada and Greenland, and then towards the Arctic, looks like you have a low pressure system in the northern areas of Hudson Bay, around getting towards Baffin Islands, and it looks like the biggest area of low pressure is this one over Eastern Asia, stretching from, looks like, about the North Pole to down to like South China and even into Vietnam. So that should be interesting to check out. Anyway, moving on. This is the 24-hour temperature change. So this is the temperature change that happened in the past 24 hours. Looks like we have much cooler air over the Great Lakes region, but that makes sense considering we have a big trough set up there. Looks like some cooler temperatures here into northern plains, into Canada, Saskatchewan, Alberta, so southern British Columbia, southern Alberta, southern Saskatchewan, and then getting into northeastern United States. Looks like we actually have warmer temperatures than we did yesterday, but looking at towards the eastern United States, the far eastern, where I said my buddy is, it looks like the jet stream, since the trough is a little bit more to the west, the temperatures are not as cool as they were previously a couple days ago, because the trough was centered more towards a little bit more eastward over the New England and Mid-Atlantic region, and now it's kind of a bit more westward over the Great Lakes, so that makes sense right there. And then looks like temperatures haven't changed much over the west, although it looks like in the center valleys of California, it looks like temperatures are warmer than they were yesterday, and then cooler down here across Texas and Mississippi, Alabama region. Now moving into looking at some satellite imagery. Currently, this is infrared imagery across the continental United States. Looks like we have some clouds over the Dakotas and stuff. Actually, some of this could be combined with, let's take a look at the visible real quick. Some of this could be combined with smoke from the wildfires out west. Like I said, that huge ridge really, really enhances the fire risk. We have some clouds over the northeastern United States. It's overcast at my house. I noticed at my house at State College there was some... the parking lot in front of it's wet, so it's some showers and clouds, so it's not a very nice day, I guess, over here. And then I guess looking at some water vapor imagery, looks like we have some areas of water vapor aloft, which might be kind of those thunderstorms that are triggering the wildfires in the west. Might be some elevated thunderstorms there. And then moving eastward, kind of looks like we have a little bit of a boundary right here, like a cold front or something that looks like that, because we have that southwesterly flow aloft here, and then looks like here you kind of have more northwesterly flow. So actually we could open up a new tab and check out a surface map real quick. Okay, so it doesn't look like it kind of looked like a cold front on the satellite imagery, but it looks like it flows still out of the southwest. But it looked like there was moving. It looked like there was that little boundary there to the west that's pushing through. So that looks like where the front is based on the surface observations. Anyway, moving ahead into more of the kind of pattern and the long range first, I guess. These are the 8 to 10 day 500 millibar height anomalies across the northern hemisphere. You got your ECMWF on the left and your GFS on the right, and it looks like there's a bit of a trough occurring in the northern plains into the Great Lakes region, more centered over the Great Lakes region. GFS doesn't have it as pronounced and has a little more eastward over New York State, but the Euro has this huge ridge, it looks like, over eastern New England and into New Brunswick and Nova Scotia and Quebec province of Canada. So maybe and then the GFS has it too, but it's not as pronounced. And then obviously the ridge in the west is still here on the Euro, although the GFS actually has a little bit of a ridge more eastward over areas like Wyoming, Montana, Colorado, and kind of a little bit of a low extending from northwestern territories into British Columbia. So that should be interesting to see, because there's some differences between two model outputs. Across Europe, consensus is that there's a ridge, and I'll get to that later, but Europe's experienced some really, really hot weather, and then, more Eastern Europe into like Eurasia area, a bit of trough, so that's consistent with what we saw on the GFS. So here's, let's look at some ensembles real quick of 500 millibar height anomalies. This is the ECMWF right here, and This was ran at 0Z today. So looking out a bit, it looks like we have first of all we have a little bit of troughiness in the east, like you saw on this page where you have that area over the Great Lakes. But then it looks like it weakens a bit and this flow becomes more zonal, and then a little bit of a ridge builds in, weak ridge builds in about 0Z Monday, July 6th. So that ridge moves out, and then it looks like another trough is kind of building again in the the Great Lakes region, the upper Great Lakes region, and a little bit of a ridge again in the west. So sadly, it doesn't seem like this ridge in the west is going away anytime soon, because those western areas need water because the fire weather risk and the drought. And it kind of looks like this is the GEFS. So this is a GFS. These next two ones are GFS ensembles. And starting off, this was ran at 6Z today. And starting off, we have a trough in the east, a big ridge in the west, and it looks like it'll kind of moderate a bit across the northern continental United States, and a little bit of ridginess again, in the east. So it looks consistent with what the EPS has. And then it looks like the flow becomes more zonal for a brief period of time, but then it looks like, according to the GEFS, that there's a big ridge building into the Rocky Mountains area and the Western Plains. So that'll be something definitely to watch. And then moving ahead, it kind of looks like that pattern kind of holds a bit. So moving ahead now to the next, this is the GEPS. I'm not exactly sure what the difference is between the the GEFS and the GEPS are, but this was also ran at 0Z, and again it has trough in the east, ridge in the west, and it looks like that pattern is again going to moderate a little bit, but again it looks like kind of like that ridge building in over the Rocky Mountains and to the Western Plains. So luckily for the people over there, if this ridge does build in and this pattern holds true, that'll keep severe weather kind of at a bit of a lower chance for severe weather because of the ridge there. And now looking into this is the we'll start with this. This is the NAM 500 millibar heights and vorticity. So this is ran at this was 12Z run of the NAM, and currently, trough in the east, ridge in the west. We got a lot of short waves and vorticity maximums towards the eastern United States, which is going to help kind of kick up, help provide lift to create showers and storms. According to the, this is 18Z today, so 2 p.m. today, it looks like we kind of have a little bit of a frontal boundary around western Pennsylvania into western New York and stretching down into Ohio and into northern Kentucky right here. And then we have this upper level low swing through, and this is now 18Z tomorrow. And then the upper level low looks like it's still going to be spinning up and kind of keeping the trough around in New England, but then it kind of looks like it moves away, and then pattern moderates a little bit, and we have all these vorticity maximums over here in the Midwest, so that'll be something to watch for, I guess, some severe weather. So here's the GFS 6Z run, and again it shows this upper level low spinning up in the east, but then it kind of looks like the pattern is going to moderate a little bit. And then looking farther ahead, it looks like again it's kind of consistent with what those 500 millibar height anomalies showed, that there's a bit of a ridge in the east right here. And the pattern gets a little more zonal, but again the GFS kind of has that you see there's that ridge over the central United States, and then pattern looks like it's going to stay relatively zonal, although it looks like there's going to be another kind of another ridge building in the west, and it'll propagate eastward. So and then kind of like it looks like the GFS kind of has that like reforming. And that looks like a very big ridge. But again, this is 384 hours out, so the amount that I would trust the model that far out is kind of not much. So here's the 0Z run of the Euro, and it kind of initially, like for the short term sim kind of deal, upper level low spinning up in the east, ridge in the west, and then pattern getting a little more zonal, but then it looks like it has another ridge forming over the Four Corners region. And then this looks like it has this big, just like what the 500 millibar high anomalies showed on the E-wall with the ECMWF, this big trough here over the northern Great Lakes into the northern plains. So that'll be interesting to watch. And it looks like it'll move eastbound towards the end of, towards the middle of July. So I guess looking at the precipitable water values real quick to kind of track where the moisture is gonna go and set up. Here's the 12Z run of the NAM, and looks like there's some dry air intruding into the northeast United States from Canada. A lot of moisture looks like over like Missouri, Illinois, Kentucky, Indiana, Tennessee, Arkansas, and then kind of moving out through the mid-Atlantic states. But according to the NAM, it looks like that the northeast is going to be kind of spared of these higher precipitable water values. But you see that big contrast right here, so that could be kind of interesting to watch right there. I know we're supposed to have a relatively wet pattern for this week in the northeast United States. So here's the 6Z run of the GFS, showing again kind of some dry air intruding from Canada, but a lot of moisture over the southeast. But then it looks like the moisture is going to reach, the GFS appears to have the moisture reach a bit more north than the NAM did. And then we have this GFS has this plume up in Canada right here of precipitable water from Saskatchewan into Manitoba and Ontario, kind of dipping downward into the United States and causing a big plume of precipitable water values over the Midwestern region, Great Lakes region, to the northeast and southeast. So lots of precipitable water over the eastern half of the country at this time. And then going into the Euro, this is the 0Z run of the Euro. Looks like same kind of deal, but the dry air intrusion, the Euro doesn't have it as much until about Friday, 12Z Friday, but it looks like there's a little bit of moisture that's going to be built into the region on Saturday here. And then the Euro looks like it's showing that plume coming down from Saskatchewan, Manitoba, Ontario into the United States and setting up over here and moving more into the northeast. The Euro has it more northward into the northeast than into the southeast. So actually there's something I'll say. I know the GFS has a positive NEO bias that the Euro does not. So right now I'm favoring the Euro more so because the NEO is more negative, is in the negative phase. So the GFS having that positive bias, I would favor the Euro more than the GFS due to its model biases. So I guess now looking at, this is the GFS, let's take a look at 2-meter temperatures real quick to get an idea of how hot it is, especially over the west, because that's where the big heat is in this in North America right now, in this part of the world. This is 0Z tonight. So it looks like we have temperatures, in the 90s and hundreds, especially in the valleys. That's where it gets really hot. The heat looks like it's staying around, but I know I did see some relief for like the very Pacific Northwest in like Washington State. A little bit of a upper trough there, I believe that could be moving in. Yeah, it kind of shows it a little bit, but it's not as pronounced as it was a couple days ago when I was looking at it. And let's see, taking a look at instability real quick. This is 12Z NAM, 6Z GFS, 0Z Euro, and for Cape values, and then this is 12Z NAM and 6Z GFS for convective inhibition. So it looks like we have a lot of instability over the eastern portions of the United States for 0Z this evening. Combined with those vorticity maxima that are going to be passing through the region, I would not rule out the chances for showers and thunderstorms because the instability is there, and those 500 millibar vorticity maximums will trigger lift. So that could potentially, generate storms. So I guess now we'll kind of take a break from the U.S. And we'll move elsewhere. So looking back at I said we're going to go back to the global circulation later. So now we're going to focus more on Europe. So we'll go back to the 500 millibar winds, and you'll see again, just to reiterate real quick, that there's this huge ridge over Europe, Western Europe, that'll affect hot air from Africa into Western Europe, and especially that the Mediterranean Sea gets a bit narrower towards Western Europe. I expect the moderation of the hot air from Africa to be less than if it was over Eastern Europe, or like around Greece and the Mediterranean countries, just because there's less water for the air to pass over. Now, looking at the surface winds, and let's put temperatures on here. You see that there's this real hot air also over in Western Africa. I mean, over here looks like 46.3 Celsius, so that's about 117 or so Fahrenheit. And this air will advect into Western Europe. Let's see, over here around the France and Spain border. 38.3. So that's almost like about 100. That's almost 100 degrees Fahrenheit. And this is in Western Europe and France, which is usually not as it's a little bit similar to the west coast of the United States in the sense that it doesn't usually get this hot. And it doesn't usually get as cold as we do in the winter. Like, for example, Madrid, Spain is about the same latitude as New York City. But New York City in the winter, if you look at the temperatures in New York City and Madrid in the winter time in like January, New York City is going to be a lot colder than Madrid. And that's because the flow from New York City is, since we're on the leeward side of the continent, since the flow is, geostrophic wind flow is primarily out of the west, or is out of the west at mid latitudes, flows from west to east. Our air is being blown from continent, from Canada or from the interior continental United States, when theirs flow will be right off the Atlantic Ocean, so they'll have more moderate temperatures than we will. We'll have more extremes, and in the summertime, a lot of times it could get hotter in New York City than it could in Madrid. Although right now it's not the case because Madrid is under this big ridge and has this really hot air from the Sahara, Sahara affecting into Western Europe. So looking at the ensembles now for over Europe, this is again the same ones, 0Z, EPS, I believe this is the 6Z, GEFS, and then the 0Z, EPS. Okay. So we have this 594 decameter ridge over Western Europe. So it kind of is a similar deal to what's occurring over the Western United States, although this ridge isn't as prolonged as the one over the Western United States is and was. So looking ahead in time, looks like we're going to have really, really warm anomalies over, Germany into Poland, Lithuania, Estonia, Latvia countries into the Nordic countries, Sweden, Finland, Norway. Looks like we even have 591 decameter thicknesses over there, and this is for 0Z on Friday, so Thursday evening. Well, for us, they're actually around a little bit after midnight, I guess. So moving in, it looks like the ridge will really be enhanced around Friday, Saturday, and some real hot air over Europe. But when I was looking out in time, looks like the pattern's going to shift a little bit because the NAO looks like it's starting to kind of transition again from its negative phase to a positive phase, and I see that we have our ridge kind of decreasing and zone flow becoming more zonal. Still warm anomalies over Europe, but definitely not as pronounced 240 hours out by July 10th than they were, on the Independence Day right here. So this is the GEFS, and again we have very warm anomalies over Western Europe and kind of getting into Eastern Europe. And again, it really builds over the Northern Europe into the Nordic countries. Very pronounced. Again, this is Thursday and going into Friday. Very big ridge. GEFS has it bigger than the Euro, but I believe as well as time goes on, the pattern starts to shift and becomes more zonal, and temperatures will moderate a bit and kind of go back a lot closer to normal. And again, this is the GEPS ensemble, and again, very warm anomalies in Europe, but then this model also shows the pattern becoming more zonal, and temperatures by this time will probably be a lot closer to normal. Still a bit above, but not as hot as it is currently right now. So going into some of the model data, this is the GFS. They don't have the NAM for Europe because the NAM is only exclusive to North America because it stands for the North American model. And pretty much you see this big ridge enhanced, but over Europe, and it kind of propagates eastward, like I said, into the Nordic countries. 588 decameters over like Sweden. That's very impressive. You got this big upper level low spinning up over in the North Atlantic right here, kind of northwest of Great Britain and the UK, and that upper low is what I think is really driving the ridge over Western and Central Europe. In that that typical trough ridginess pattern, but it looks like the upper level low will kind of move eastward as time progresses, and it looks like it'll kind of weaken. So the flow becomes more zonal, and it looks like you have a little bit of a ridge over here about 240 hours out. But then it looks like you have a bit of an upper trough, upper level low moving into Western Europe. So then that'll make things a bit cooler. And then again, it looks like another shot of an upper level low moving into like the UK and then into Western and then Central and Eastern Europe there. I guess we'll take a look at the temperatures real quick, just because Europe is, experiencing some real record heat. Temperatures, in the 90s, 80s, and 90s in France, and looks like there's some areas of some isolated triple-digit heat. So that's triple-digit heat's very uncommon in Europe. It looks like the only place in like Western Europe maybe you could get some relief, not counting the UK, because the UK is kind of on its island of its own, is the Alps, just because the altitude, and it looks like moving out in time when the pattern starts to become more flow, the flow starts to become more zonal, that the temperatures will moderate a bit and get closer to normal. The Euro, this is the 0Z of the Euro, and again, it shows that big ridge in over Europe, but it's weakening as this big upper level low starts to move closer into Western Europe, and then flow becomes more zonal, and then the low looks like it'll be moving into the region, so that'll probably drop the temperatures a bit. And then I guess looking at the precipitable water values, so that was just the Canadian model anyway. The Canadian always has issues, so it's not the end of the world that I X'd out of it by accident. Anyway, this is the precipitable water values, and it looks like we have some plumes of high precipitable water over France. So maybe I wouldn't rule out a shower or a thunderstorm. And I guess kind of to wrap up real here, that ridge in the over Europe looks like it'll weaken, so hopefully, Europeans will have some relief in sight with this heat, because I don't believe many people in Western Europe have air conditioners. Although the ridge in the west looks like it'll still be persistent, a lot more persistent than that ridge in Europe, so hopefully, the pattern will change, but it doesn't look like it's going to change all too much, maybe a little bit, but definitely be careful with that fire weather out there towards the west. So I guess this will wrap things up in this discussion. This is, again, student meteorologist Eric Drewitz with Weather International. Please like my page for your latest forecasts and weather updates worldwide. And thank you for your time, and have a very good day.